Welcome back to this lecture 1 polynomials. So in this lecture we'll discuss previous year questions 1 polynomials. So in your previous lecture we have started to solve previous year questions 1 polynomials. Okay, so in this lecture basically we'll continue the previous year questions 1 polynomials. So let's get started. So in our previous lecture we have solved question number 1 to question number 7. Okay, and here in this lecture we'll solve from question number 8. So in this question we have given these informations: sum and product of zeros are 2 and minus 1 respectively. Okay, so a quadratic polynomial whose sum and product of zeros are 2 and minus 1 respectively. Okay, so student, you know, if we have a quadratic polynomial ax square plus bx plus c, okay, and then you know the relationships between zeros of this quadratic polynomial and coefficients of its. Okay, so now if we let us consider a quadratic polynomial b ax square plus bx plus c. Okay, so p of x is equal to ax square plus bx plus c, where a, b and c are real numbers and a does not equal to 0. Okay, here we have given sum and product of zeros are 2 and minus 1 respectively. Okay, so if alpha and beta are the zeros of this quadratic polynomial ax square plus bx plus c, then alpha plus beta, this is given 2, and alpha times beta, this is given minus 1. Okay, so from these relations we can find a quadratic polynomial. Okay, so here first let p of x, this is equal to ax square plus bx plus c, okay, be a polynomial, be a quadratic polynomial. Okay, where a, b and c are real numbers and a does not equal to 0, and also alpha beta p2 zeros of p of x. Okay, so here basically we let p of x, this is equal to x square plus bx plus c, be a quadratic polynomial, and alpha beta be 2 zeros of this quadratic polynomial. Okay, so we know sum of its zeros, sum of its zeros, this is equal to alpha plus beta, this is equal to minus of coefficient of x divided by coefficient of x square, okay, and for this quadratic polynomial ax square plus bx plus c, here the coefficient of x is b and the coefficient of x square is a. Okay, so alpha plus beta, this is equal to minus of b upon a, and product of its zeros, this is equal to alpha times beta, and this is equal to constant term divided by coefficient of x square. Okay, and for this quadratic polynomial, here the constant term is c and the coefficient of x square is a. Okay, so alpha times beta, this is equal to c upon a. So alpha times beta, this is equal to c upon a. Okay, so here given to us, so in this question we have given sum of zeros alpha plus beta, this is equal to minus, this is equal to 2, this is equal to 2, Okay, and alpha times beta, this is equal to minus 1. Okay, so alpha plus beta is equal to, at 2 can be written as minus of minus 2 divided by 1. Okay, and that is actually minus of p upon a. And alpha times beta, this is equal to minus of minus 1 by 1, and this is equal to c upon a. Okay, so alpha plus beta, this is equal to minus b upon a, and this is equal to minus 2 upon minus 2 upon 1. Okay, so here we get alpha plus beta, this is equal to minus of minus 2 upon 1. Okay, and alpha times beta, this is equal to minus 1 upon 1, and this is actually equal to minus b upon a. Okay, and this is equal to c upon a. Okay, this is equal to c upon a. So if we take a, this is equal to 1, then p is equal to minus 2, and c is equal to minus 1. Okay, so if we take a is 1, then we get the value of b is equal to minus 2 and the value of c is equal to minus 1. Okay, so now the quadratic polynomial is x squared minus 2x minus 1. Okay, so this is the required quadratic polynomial. So for this question, x squared minus 2x minus 1 is the required polynomial. Okay, so if you see the option, then here in option B, we have given x squared minus 2x minus 1. So here the correct answer is option number B. Okay, so now let us move to question number 9. So in question number 9, we have given this quadratic polynomial x squared minus 1. Okay, and here alpha beta are the zeros of this quadratic polynomial. Then we need to find the value of alpha plus beta. Okay, so student, you know, if we have a quadratic polynomial p of x, this is equal to ax squared plus bx plus c, ax squared plus bx plus c. Okay, then if alpha and beta are zeros of p of x, then the sum of its zeros, alpha plus beta, this is equal to minus of p upon a, that is minus of coefficient of x divided by coefficient of x squared. Okay, and the product of its zeros, alpha times beta, this is equal to c upon a, that is constant term of this quadratic polynomial divided by coefficient of x squared. Okay, so here in this question, we have given this quadratic polynomial p of x is here actually x squared minus 1. Okay, so here in this question, we have given p of x, this is equal to x squared minus 1. Okay, so here you can write this equation in the form of ax squared plus bx plus c. Okay, so this is equal to x squared plus 0 times x minus 1. Okay, so here the terms of x is not involved. Okay, so here the coefficient of x basically 0. So we can write x squared minus 1, this is equal to x squared plus 0 times x minus 1. Okay, so here if we compare this equation with this equation, then you will get here a is equal to 1, b is equal to 0, and c is equal to minus 1. Okay, so now if alpha and beta are the zeros of this quadratic polynomial x squared minus 1, then sum of its zero, that is alpha plus beta, this is equal to minus of b upon a, and this is equal to minus of 0 upon a, and this is equal to 0. 0 upon 1, and this is equal to 0. Okay, so sum of its zeros is equal to 0. That is alpha plus beta, this is equal to 0. So if you see in option, then in option D we have given 0 value. Okay, so here the correct answer for this question is option number D. Okay, so option number D is the correct answer for this question. So now let us move to question number 10. So if alpha and beta are the zeros of the polynomial p of x, this is equal to 4x square minus 3x minus 7. Okay, then we need to find 1 by alpha plus 1 by beta is equal to what? So here we have given 4 options. Okay, so in option A we have given 7 by 3. In option B we have given minus 7 by 3. And in option C we have given 3 by 7. And in option D we have given minus 3 upon 7. Okay, so here p of x is equal to 4x square minus 3x minus 7. So the general form, we know the general form of a quadratic polynomial is ax square plus bx plus c. Okay, so now if we compare this equation with this quadratic polynomial. Okay, so basically we have given here p of x, this is equal to 4x squared minus 3x minus 7. Okay, and now if we comparing the coefficients, comparing the coefficients, then we'll get a is equal to 4, b is equal to minus 3, and c is equal to minus 7. Okay, so we know sum of its zeros, that is alpha plus beta, this is equal to minus b upon a. Okay, so we have used this concept, sum alpha plus beta, this is equal to minus of coefficient of x divided by coefficient of x square, that is alpha plus beta, this is equal to 3 upon 4. Okay, and the product of its zeros, that is alpha times beta, this is equal to constant term divided by coefficient of x square. Okay, and here the constant term is minus 7 and the coefficient of x square is 4. Okay, so then alpha times beta, this is equal to minus 7 by 4. And now if we divide alpha plus beta by alpha beta, then we'll get alpha plus beta, this is divided by alpha beta, this is equal to basically 3 into 4 divided by 4 into minus 7. Okay, and this is equal to minus 3 upon 7. So now if we simplify this equation, then we get 1 by beta plus 1 by alpha, this is equal to minus 3 upon 7. Okay, so the value of 1 by alpha plus 1 by beta, this is equal to minus 3 upon 7. Okay, so this is equal to minus 3 upon 7. So now if we check options, so in option D we have given minus 3 upon 7. Okay, so for this question the correct answer is option number D. Okay, so now let us move to question number 11. So if one zero of the polynomial p of x is equal to 6x squared plus 37x minus k minus 2 is reciprocal of the other, okay, then we need to find the value of k. So reciprocal means what? So if x is a non-zero number, then 1 by x is basically called reciprocal of x. Okay, so here we have given this information. If one zero of the polynomial p of x is reciprocal of the other, that means if we have two zeros of this quadratic polynomial, suppose we have alpha and beta are the zeros of this quadratic polynomial, then if we take this relationship, say alpha, this is equal to 1 by beta. Okay, that means here 1 0 alpha, 1 0 beta, that is reciprocal of the other 0 alpha. Okay, so basically in this question given this information, so by using this information we need to find the value of k. Okay, so we need to find the value of k. So we have given p of x, this is equal to 6x squared plus 37x minus k minus 2. Okay, so here we have given this quadratic polynomial, and here we let alpha and beta be the zeros of p of x, and therefore beta is basically equal to 1 by alpha. Beta is equal to 1 by alpha, that is given condition. Okay, so now alpha times beta, this is equal to 1. Okay, and also we know product of its zeros, this is basically equal to constant term divided by coefficient of x square. So if we see this quadratic polynomial, here the constant term is minus of k minus 2 and the coefficient of x square is 6. Okay, so alpha times beta, this is equal to minus of k minus 2 divided by 6. Okay, now from this equation, this is equation number 2 and this equation number 1. Okay, so from this equation number 1 and equation number 2, we get this equation minus of k minus 2 by 6, this is equal to 1. Okay, so here we get this relation minus of k minus 2 by 6, this is equal to 1. Okay, and now if we simplify this equation, then we'll get 2 minus k, this is equal to 6. Okay, and it implies minus k, this is equal to 6 minus 2, that is 4. So then k is equal to minus 4. Okay, so if 1 0 of the polynomial p of x, this is equal to 6x squared plus 37x minus k minus 2 is reciprocal of the other, then the value of k is basically equal to minus 4. Okay, so the value of k is equal to minus 4. Now let us move to question number 12. So for question number 12, here we have to find the zeros of the quadratic polynomial minus x squared plus 2x plus 8. Okay, so here we have given this quadratic polynomial minus x squared plus 2x plus 8. Okay, and we need to find the zeros of this quadratic polynomial. So student, you have studied in your class 9, how to factorize a quadratic polynomial into two linear factors. Okay, so basically here we can use the method that is spreading the middle term methods. Okay, so here the middle term is basically 2x. Okay, so 2x, here the middle term, so here the middle term is 2x, so 2x, this is middle term, and this can be written as 4x minus 2x. Okay, so that 4x times minus of 2x, this is equal to minus of 8x squared. Okay, so minus x squared minus x squared minus x squared plus 2x plus 8 can be written as minus x squared plus 4x minus 2x plus 8. Okay, and this can be written as minus of x times x minus 4 and minus of 2 times x minus 4. Okay, and this is equal to minus of x plus 2 times x minus 4. Okay, so we get these two linear factors, x plus 2 and x minus 4. So minus of x squared plus 2x plus 8 is equal to minus of x plus 2 times x minus 4. Okay, so now for finding the zeros of this quadratic polynomial, we need to equate this quadratic polynomial to 0. Okay, so if the value of minus x square plus 2x plus 8 is equal to 0 when x plus 2 this is equal to 0 or x minus 4 is equal to 0. That is when x is equal to minus 2 or x is equal to 4. Okay, so at x equal to minus 2, the value of p of x, that is value of minus x square plus 2x plus 8 is equal to 0, and at x is equal to 4, the value of minus x square plus 2x plus 8 is also 0. Okay, so the zeros of the quadratic polynomial minus x square plus 2x plus 8 are minus 2 and 4. Okay, so the zeros of the quadratic polynomial minus x square plus 2x plus 8 are minus 2 and 4. Okay, so now let us move to question number 13. So here we have given this quadratic polynomial. Okay, and here we have given this information. Alpha and beta are the zeros of this quadratic polynomial. Okay, and then we need to find the value of alpha square plus beta square. Okay, so student, how can we think about this value? Okay, so how can you find alpha square plus beta square? So in your class 9, there you have studied some identities like a plus b whole square, a minus b whole square, a square plus b square, a square minus b square. Okay, so basically here we will use the identity a square plus b square. Okay, so recall the identity a square plus b square. Okay, so here we have given alpha and beta are the zeros of this polynomial. F of x is equal to x square minus 4x minus 5. Okay, so here if we compare this quadratic polynomial with the general form of a quadratic polynomial ax square plus bx plus c, okay, then here basically here for this quadratic polynomial a is equal to 1, b is equal to minus 4 and c is equal to minus 5. Okay, and here we have given alpha and beta are the zeros of this polynomial. Okay, so alpha plus beta, this is equal to minus of b upon a, and that is equal to minus of minus 4 upon 1, and this is equal to 4. So alpha plus beta, this is equal to 4, and alpha times beta, this is equal to c upon a, and this is equal to minus 5 by 1, and this is equal to minus 5. So alpha plus beta, this is equal to 4, and alpha times beta, this is equal to minus 5. Now we will use this identity alpha square plus beta square. This is basically equal to alpha plus beta whole square minus 2 times alpha beta. Okay, so alpha plus beta whole square minus 2 times alpha beta. So here we find the value of alpha plus beta, this is equal to 4, and the product alpha times beta, this is equal to minus 5. Okay, where a is 1, b is 4, minus 4, and c is equal to minus 5. Okay, then alpha square plus beta square, this is equal to alpha plus beta whole square minus 2 times alpha beta. And if we now put the values of alpha plus beta and alpha beta, then we'll get this is equal to 4 square minus 2 times minus 5. Okay, and this is equal to 16 plus 10, and this is equal to 26. So alpha square plus beta square, this is equal to 26. Okay, so now let us move to question number 14. So in question number 14, here you have to find a quadratic polynomial whose zeros are reciprocals of the zeros of the polynomial p of f of x is equal to ax square plus bx plus c, where a does not equal to 0 and c does not equal to 0. Okay, so we need to find a quadratic polynomial whose zeros are reciprocal of the zeros of the polynomial this. Okay, so here you can let alpha and beta be the zeros of the polynomial f of x is equal to ax square plus bx plus c. Okay, and therefore alpha plus beta, this is equal to coefficient of x divided by minus of coefficient of x divided by coefficient of x square. Okay, that is equal to minus b upon a. Okay, and the product of its zeros, that is alpha times beta, this is equal to constant term divided by coefficient of x square, that is equal to c upon a. Okay, and according to the question, 1 by alpha and 1 by beta are the zeros of this required quadratic polynomial. Okay, so 1 by alpha and 1 by beta are the zeros of the required quadratic polynomial. Then we can here actually according to questions, these are the zeros of the required quadratic polynomial. Okay, so now 1 by alpha plus 1 by beta, this is basically equal to alpha plus beta divided by alpha times beta. Okay, and this is equal to minus b upon a divided by c upon a. Okay, and this is equal to minus b upon c. Okay, and now if we take product alpha 1 by alpha times 1 by beta, this is equal to 1 by alpha beta, and this is equal to a upon c. Okay, so here the sum of its 0, that is equal to minus b upon c, and we know for this quadratic polynomial minus of coefficient of x divided by coefficient of x square. Okay, and this is equal to constant term divided by coefficient of x square. Okay, so here actually the required quadratic polynomial is is here the constant term is a. Okay, and the coefficient of x square is c, so c x squared, and the coefficient of x is b. Okay, so plus bx plus a. So this is the required quadratic polynomial whose zeros basically the reciprocals of the zeros of the quadratic polynomial ax square plus bx plus c. Okay, so now let us move to question number 15. So if alpha beta are the zeros of the quadratic polynomial x squared minus 5x plus 6, and from another quadratic polynomial whose zeros are 1 by alpha and 1 by beta. So from another polynomial of whose zeros are 1 by alpha and 1 by beta. Okay, so here basically you have given this quadratic polynomial, and alpha beta are the zeros of this quadratic polynomial. Okay, so sum of zeros of the required polynomial is basically 1 by alpha plus 1 by beta. Okay, and that is equal to alpha plus beta divided by alpha times beta, and this is equal to minus b upon c. Okay, so now the product of its zeros, that is 1 by alpha into 1 by beta, this is equal to 1 by alpha beta, and this is equal to a by c. Okay, so from now equation of the required quadratic polynomial is equal to k times x squared minus sx plus p, where k is any non-zero constant. Okay, and this is equal to k times x squared minus b upon c x plus a upon c. And if we simplify, then we get this is equal to k times x squared plus b upon c times x plus a over c. Okay, so now here we have given this quadratic polynomial x square minus 5x plus 6. So alpha plus beta, this is equal to 5, and alpha beta, this is 6. So sum 1 by alpha plus 1 by beta, this is equal to alpha plus beta divided by alpha beta, this is equal to 5 by 6. Okay, and the product 1 by alpha into 1 by beta, this is equal to 1 by alpha beta, this is equal to 1 by 6. Okay, so therefore the required quadratic polynomial is k times x squared minus 5 by 6x plus 1 by 6, where k is any non-zero constant. Okay, so this is the required quadratic polynomial. Okay, so I stop here this lecture. Thank you very much to all of you.